So we have these three different states of matter: solid, liquid, and gas. And we've talked about how the atoms are arranged in each one. And we've also talked about how they behave in each one. So in a solid, they vibrate around fixed points. They're touching, they're in a pattern. Liquids, they're touching or very, very close. Same as a solid, actually, they might just be very, very close. They're not arranged in a pattern in a liquid. They're able to flow by each other, but they will stay together as a group. In a gas, the particles are not touching. They're spread out, and they're going to fill the container. They move very, very quickly. Now we can probably demonstrate that. Actually, what I tend to do when I'm drawing these diagrams is draw reasonably big arrows in random directions, just to show that they're all sort of moving in random directions, and the size of the arrow shows that they're moving fairly fast. Okay, and then over here in a liquid, they're still moving, but smaller arrows, because they're not moving as fast. And you can see that they're all staying together as a group. Okay, I'll have to draw not all of them, but yeah. So that just shows you, that's kind of a diagram showing how they're moving around. In a solid, I did these little lines here to show that they're vibrating back and forth. What we want to know now is, what is it called when you change something from a solid into a liquid? So what's that process called? So yeah, we're going to heat it up, which is well, I've got this red arrow. The process is called melting. Okay, so you said melting, so we would just want to label that as melting. So what about the opposite? What about if we went from liquid back into a solid? What would we call that? It is going to be cooling, but when it actually changes from a liquid back into a solid, that process has got a particular name. Not just, yeah. Yeah, but more specifically, think about when you got a liquid turning into ice. What would you say that's happened to the water that's turned into the ice? Yeah, that's right. So when a liquid turns into a solid, we say it's freezing. That process is called freezing. Now, weirdly enough, people always think of freezing as meaning cold. If something is freezing, it's really cold. But of course, it doesn't have to be that way. Cold and hot is all relative. So in other words, if we think about something that's really a liquid that's really, really hot, like I'll get a picture to show you what I mean. So this is a liquid, right? You can see it's a liquid. It's flowing like water. But what is lava? Well, lava is just melted rock. Now, if I let that lava cool down, then when it turns from a lava into rock, that is freezing. We might use the word solidifying. Sometimes they use the word solidifying, but freezing is completely accurate. Whenever anything turns from a liquid into a solid, it is freezing. That's what it means. It started off with a very hot liquid, lava, and it turned into stone. But that process is called freezing because it's turned from a liquid into a solid. So we still use the word freezing. And again, this is when science gets a bit confusing, because you think, hang on a second, that's not right, because freezing means cold. But the way we speak in everyday language isn't necessarily the same way. It's not always 100% accurate. Usually, things that are frozen are cold, but not always. You can have some stones that are really, really hot, but because they're still solid, we still say they are frozen, right? So everything that's solid is technically frozen. It's not melted. So yeah. And likewise, we use the word boiling to mean that it's really hot. But if something is still a liquid, it's not boiling. It's in fact that would be my next word then. So which of these two arrows means boiling? Right. So basically, we can say that one is boiling. Now it does have another word. Boiling is one word we can use, I'm going to put that in brackets. No, I won't. I won't put it in brackets. I'm going to say boiling. I'm going to say, for now, I'm going to say or evaporating. But what I will, I'm going to bold and underline evaporating, because evaporating is a better word to use, because sometimes something will turn into a gas without it boiling. For example, if you spill a little bit of water on the surface on while you're pouring a glass of water and you don't wipe it up, you look again in about an hour's time, the water's not there anymore, is it? So yeah, it'll be a little bit damp, but maybe if you look tomorrow, it won't even be damp anymore. So the water has actually turned into not steam, but water vapor, which basically means it's a type of gas. It's water. It's a gas, basically. So, and that's evaporating. When you are boiling something, what that really means is that all the particles are, on average, they have enough energy to evaporate, whereas you can have evaporation below boiling point. So you can have evaporation even at very cold temperatures. So yeah. All right. So, but boiling is slightly different to evaporating. So evaporating is a better word to use here. So this is the one that people mostly forget when you go from a gas into a liquid. Can you remember what that's called? I'll give you a clue. If let's say you have a hot shower, you'll notice the mirror on the shower will have. Say again. What did it? So yeah, we'll say lots of steam is coming out of the shower. So that's like the water vapor that turns into liquid water, and you get water droplets on the mirror. But what do we say that's called? Right, excellent. So now we've used the ing at the end of it, so we're going to say condensing. Condensation's fine, but just to be consistent, just to make it accurate, we've said freezing, melting, evaporating, condensing, boiling. Okay, so those are the so each picture is a state of matter, and these arrows describe state changes when it changes from one state of matter into another. So when it changes from gas into liquid, or liquid into gas, and so on, their state changes. Now there is one more. So it looks like there's going to be only 4, but there's actually one more. Some substances skip out the liquid stage altogether. They go straight from gas to solid. One of the substances that do that is carbon dioxide. Just press undo there when it does that. If you just press so for example, carbon dioxide, it doesn't have a liquid stage. There is no such thing as liquid carbon dioxide. You can have solid carbon dioxide, which is confusing as well, because we think, hang on, carbon dioxide is a gas. It's in the air. It causes global warming. It's a gas. But if it's cold enough, it's a solid, just like anything else. If things are hot enough, they become gas or liquid. If they're cold enough, they become liquid or solid. So, but you cannot have liquid carbon dioxide. So when you cool carbon dioxide gas down, it just jumps from a gas straight to a solid. And that process is called sublimation. So we need to draw another arrow there. So I'm just going to draw that and label it. So there's my arrow. Now what you can also do is you can click on this arrow here and you can add text. So I click there. And I'm going to... is it typing? Okay, let's see what happens. Sublimation. Oh no. Let's try that again. Come on. Okay, let's try it. Sublimation. It's probably typing it very small. So I'm just going to make it a bit bigger. Oh, let me just pause this video. So there we go. So that is called sublimation. That's the one other one. Okay. I'll stop sharing my screen. So I'll save that video.